Hello, and welcome to this Anatomy Physiology Bio 201 video lecture on articulations of the skeleton. I'm Mr. Kennedy, and I'll be your guide as we explore this topic together briefly. We begin today by asking the question, what is a joint? A joint is a point of contact between two or more bones, cartilage and bone, or teeth and bone. Joints can be classified structurally or functionally. In their structural classification, we look for the presence or lack thereof of a joint cavity and what kind of connective tissue holds them together. Functionally, we look at what kind of degree of movement is permitted to classify a joint. Here we see the structural classification of joints summarized. There are three categories: fibrous, cartilaginous, and synovial. Fibrous joints are joints like sutures, which are held together with dense fibrous connective tissue. Cartilaginous joints include things like synchondroses. Synchondroses are held together with hyaline cartilage and permit no movement. Synovial joints involve articular cartilage on the ends of long bones and a synovial cavity between the articulating bones, surrounding by accessory ligaments. Synovial joints are freely movable. Here are the three categories of joints classified functionally: synarthrotic, amphiarthrotic, and diarthrotic joints. Synarthrotic joints allow no movement, amphiarthrotic joints allow little movement, and diarthrotic joints are freely movable. Fibrous joints lack a synovial cavity. Fibrous joints articulating bones are held together with dense fibrous connective tissue and permit little or no movement. Types of fibrous joints include sutures, syndesmoses, and interosseous membranes. This graphic provides you with an example of a fibrous joint in the skull. Here we have interosseous membranes and a fibrous joint in the jaw between the jawbone and a tooth. Cartilaginous joints. Cartilaginous joints also lack a synovial cavity. Cartilaginous joints articulating bones are held together with cartilage connective tissue and again permit little or no movement. Types of cartilaginous joints include synchondroses and symphyses. This is an example of a cartilaginous joint. Synovial joints. Synovial joints have a synovial cavity. Synovial joints articulating bones are covered with articular cartilage held together by ligaments. They contain synovial fluid, have a nerve and blood supply, and are surrounded by an articular capsule. Synovial joints permit a large range of movement. Here we see a stereotypical synovial joint. Bursa and tendon sheath. Bursa and tendon sheaths can be found at many synovial joints. Bursa are sac-like structures filled with synovial fluid that cushion movement of one body part over another, while a tendon sheath is simply a tube-like bursa that wraps around a tendon, specifically a tendon that is subject to a great deal of friction. Types of movement at synovial joints. Here we see a variety of movement types at synovial joints summarized in a single location. Hyperextension, extension, and flexion of the neck, as an example. Hyperextension, extension, and flexion of the shoulder. Elbow joint and wrist joint are also seen here. Take a moment to familiarize yourself with the different types of movements at synovial joints. Here we have abduction and adduction at the shoulder joint and the wrist. On this slide, we see circumduction using the arm and the leg. Here we have rotational movement. We see rotational movement of the hip and the shoulder, as well as the neck. And here we see protraction and retraction. We can also see inversion and eversion, and supination and pronation. This table will provide you with a summary of the movements at synovial joints. Each movement type is listed with its description. Again, be sure to familiarize yourself with each movement type and exactly what's occurring. Next, we'll examine some more movements at synovial joints. Here, we'll examine a joint known as the plane joint between the navicular and second and third cuneiforms of the tarsal of the foot, a hinge joint between the trochlea of the humerus and the trochlear notch of the ulna at the elbow, and a pivot joint between the head of the radius and the radial notch of the ulna. Next, we see a biaxial joint between the radius and xiphoid and lunate bones of the carpus in the wrist, and a saddle joint between the trapezium of the carpus and the metacarpal of the thumb. We also have a ball and socket joint between the head of the femur and acetabulum of the hip bone. Factors affecting contact and range of motion at synovial joints. The structure and shape of the articulating bones play a huge role in the range of motion at a synovial joint. Strength and tautness of the joint ligaments, the arrangement and tension of muscles, and contact of other soft parts can also impact the movement of synovial joints. Hormones and disuse can also play a role in reduction of movement at synovial joints. Next, we'll examine some selected joints of the body. This is the temporomandibular joint. As we go through each of these, it's important that you pause briefly to familiarize yourself with each labeled structure in these diagrams. Here's another view of the temporomandibular joint. And one final view of the temporomandibular joint and its synovial cavity. Next is the shoulder joint. Again, take a moment to pause the video and familiarize yourself with each labeled structure. This is a slightly different view of the same joint. A third view of the shoulder joint. Be sure to pause the video and identify and familiarize yourself with the labeled structures on each of these slides. This is a cadaver section of the shoulder joint. Next, we have the elbow. This is your hip. Again, pause the video briefly and make sure you're familiar with each labeled structure. Here we have your knee joint, probably one of the most problematic joints in the entire body. Make sure to familiarize yourself with each labeled structure of the knee joint. Here's a sagittal section of the knee joint. This is the anterior superficial view and posterior deep view of the knee joint. And finally, cadaver sections of the knee joint, both in anterior and posterior view. And this concludes our overview of the articulations of the skeleton.